Hello everyone, and welcome to our webinar. My name is Oren Elias, and I am the General Manager of CoderZ at Intelitek, and very glad to welcome you to our second webinar in our series of STEM webinars. Just for those of you who are not familiar with us, Intelitek has been a pioneer of robotics in education for over 30 years. Our latest innovation, CoderZ, is an online learning environment that gives students worldwide the opportunity to program virtual robots using 3D engaging simulations while meeting key STEM curriculum goals. CoderZ makes robotics for education accessible, affordable, and enjoyable for all. You can learn more about CoderZ by visiting gocoderz.com or by following CoderZ on Facebook or Twitter. One of the toughest questions we always face when introducing new STEM programs is how can we measure success? How do we know if our program is effective? Today, we're going to talk about why it's so hard to measure and look at some innovative approaches to solve this problem. A few technicalities before we begin. I encourage all participants to submit questions throughout the event. To submit a question, simply type it in the chat box in the lower corner of the GoToWebinar control panel. And now, I'm very proud to introduce our speaker, Oded Reichsfeld. Oded has almost 3 decades of experience innovating, researching, and leading numerous educational projects. Oded has won the Teacher for Life Award from the Technion Institute of Technology. He has also recently won the Teacher of the Year Award. He is a founding team member of the Mechatronics programs in the Ministry of Education and has been a senior member of the assessment and evaluation team for many years. Today, Oded is also Intelitek's Director for STEAM and Pedagogy. Oded, the audience is all yours. Let's see, perhaps we have some technical difficulty. Oded? Please excuse us one moment while we try to figure this out. I apologize for the delay. 1 second. Apologies, everyone. It seems we have a technical difficulty. Please excuse us while we try to sort this out. Apologies, everyone. It seems that Oded has had a technical difficulty and he's now rejoining. Please bear with us while we try to sort this out. I guess it's Murphy's Law that no matter how much you prep, these things happen. Again, thanks for the patience. Okay, we indeed hit Murphy's Law. Apparently there was a power outage. Please bear with us and we will start in approximately 3 minutes. In the meantime, if there are specific questions around measuring effectiveness of STEM programs or topics you would like Oded to refer to, then feel free to send it to us over chat. And again, we will start in approximately 3 minutes. Thank you so much for your patience. Again, everyone, we should get this all sorted out within a minute or so. Thank you for holding on. Okay, I just got word from Oded. He's trying to dial in now. Again, this was a power outage in the entire area, apparently. But he is regaining power now and trying to dial in. Again, thanks for the extreme patience, everyone. Um, again, Murphy's Law is struck, so hopefully we'll be well on our way in just a few minutes. Okay, Oded is with us now on the line, and we'll be transferring control over.
Okay, so
Excellent.
excellent. Okay,
So first of all, thanks everyone for the patience, and again, I think that it proves that Murphy's Law is always right. And again, proud to introduce Oded, who's with us now, and we'll get started right away. Oded, the audience is all yours.
okay. So first of all, I'm sorry for the problems that we had in connecting this webinar. And basically, this webinar is somewhere about it. I mean, even doing this webinar is, in a way, it's a miracle, because 10 years ago, nobody could think it is possible, and this is basically what I'm going to talk about it. But I will start, first of all, by by presenting myself. Well, my name is Oded Reichsfeld. I'm an educator for the past 30 years. I love students. I love very much students. I love human beings in all, and I love technology. And what I'm doing for the past 30 years is to combine these two loves together. I love the students. We teach technology, and through technology, the students learn and find themselves, find them strengths. Um, can you see my screen? In a minute. Can you see my screen?
Excellent.
Okay. So can we start?
Go ahead.
Okay. So this seminar is about assessment in STEM and robotic learning environment. My name is Oded Reichsfeld, and I will start with presenting myself. So a little bit about me. You can see me there in the black shirt with my students. My name is Oded Reichsfeld. I'm an educator for the past 30 years. I love students, and I love technology. And what I did in these 30 years, and what I'm hoping to do next, is to combine these two loves together. I teach the students. We use technology to teach them, and my aim as a teacher is to provide them with a better future. I'm doing this also as a director for STEM curriculum and pedagogy at Intelitek. And I believe that education is the right answer for the three goals that direct me in my life. First of all, I think that education can improve students' life, because when a student is educated properly, he will have a better life, because he will know better how to manage his life, how to adjust to changes that occur in his lifetime. And I believe that if the student life is better, then the society's life is better. So by helping the student, by strengthening the students, we get a stronger society. And of course, a stronger society and a just society gives us what we call equal opportunities. So education, in my opinion, is one of the best tools to make a better society. And this is what we are doing. This is, as teachers, this is the service that we give our society. So this webinar is about the educational design process. The design process is something that engineers use to do in order to solve problems. And I will take this tool, this engineering tool, to solve an educational problem. And we will ask ourselves why, how, and what we should do at schools. So what you see here, this is the problem-solving loop. This is basically how engineers solve problems. They start with identifying the problem, then they explore information and create ideas based on this information that they gathered. They select the best idea, they build and test it, and after this idea is built, they evaluate the results, and usually the results pop up another questions and other problems that they solve. And this is how engineers work all the time. For example, if we take cars or computers or electronics, we see that there is a constant evolution, because every time when a problem is discovered, this problem-solving loop is activated. And we will do it with education. So the first thing I want to raise here is, what is the problem with education? So the problem with education is presented here in this Moore's law. Moore's law is about singularity. It shows that from 1970 till 2005, the price of the number of transistors you could buy for the same price rose by 100,000 times. Just to give you an example, in 1970, I was 8 years old, and Apollo landed on the moon. And in 2004, Facebook was established. Now, my teachers could not predict that Facebook will be established. They could not imagine anything. So, and of course, we are facing the same problem. We don't know what the future of the students, what will be the world like when they will be adults, like I am. Because if we look on how engineers solve problems, we can see, for example, that the way we listen to music changed radically in the past 120 years. And every time a new innovation was shown or something else was invented, the way we listen to music changed. And I don't know from what is your age, but I think that children that are born today, are living today, they don't even understand why we need something to listen to music, because they listen to music through their smartphones. Now, this is basically the problem of education. We can't predict what the future will look like. We have this small child standing here, looking forward, and the question is, what should we give our future citizens today? This child is going to school. What we will do with him? How we will prepare him to the future, which we don't know how it will look like. And this dilemma here is shown by these two emojis, is whether we should teach him knowledge or should we teach him to think. Now, the question or the debate between thinking or knowledge has already been decided by our governments, because our governments say that we want to teach the 21st century skills. We are already 17 years within this century, and still they are talking that we should teach the 21st century skills because we are not doing it. But what are the 21st century skills? First of all, we want the student to be a problem solver, that he will be able to solve problems, to understand problems, to solve them, to get information, the same process that we are doing now. He should be an idea communicator, which means that he can talk with others, he can gather information, process it, show it, use it, share it. He should be able to work in teamwork, and he should be creative. But none of this is happening in most of the schools. And the question that I want to raise here is why? Why? How should we teach the 21st century skills? So, like all engineers, we will go and explore information. I want to start with one famous educator that shaped the way our schools look today. His name is Ivan Pavlov. Ivan Pavlov was born in the 19th century in Russia. He died at the age of 86, and he is the father of the classical conditioning theory. He is a Nobel Prize winner, and he was famous for his conditioning experiment. He took a dog and gave him, sounded a bell and gave him food. And after some time, the dog learned that immediately after the bell is sound, he gets food. And so the dog began to salivate when the bell was sound. And this is called classical conditioning, because the dog learned how to react to a certain condition. And this is basically what we do today in schools, because what we give our student is a bunch of exercises, and we tell him how to solve them. And we test the way the student solve these problems, and this is how we evaluate them. If you can solve this problem, then you are probably a good student, and if you can't solve them, then you are probably not as good. But the problem is that there is no thinking in here, or if there is thinking, it is a very, very low level thinking. Solving such exercises doesn't cause the student to exercise the 21st century skills. So how we can teach students to think? It is quite difficult, but there is an answer. Another Russian named Lev Vygotsky, that also was born about the same time in Russia, about the end of the 19th century, but he died at the age of 37. He said he's the father of the development of higher cognitive function. And this is basically what we are looking. There is low cognitive function and higher cognitive function, and he suggested a theory on how to develop them. He said that through others, we become ourselves. And this is very, very important notation. It means that we are shaped by our environment. If we live in an environment that shapes us to be thinkers, critical thinkers, entrepreneurs, designers, whatever, then this is what we will be. And if we are born in a society or in an environment that depresses us, that lets us to think that we are not smart, we are not capable, we are not able to create something new, then this is what we will believe. So he suggested that what we should provide the student is something that is called learning environment. Now, his idea is very, very simple. He said that we can divide the world into two areas. Things she can do in yellow, and things she can't do, which is the greater circle on the periphery of the yellow one. And the learning environment is this very, very small ring around the things that she can do. In this ring, there are things that she can't do, but she can do them with help. This zone is called the zone of proximal development, and it is this was suggested by Vygotsky. And he said that a good learning environment has a bigger zone of proximal development, while a not so good learning environment is experienced in a shorter zone of proximal development. This notation of Vygotsky is very important because he said that it's not, it doesn't really matter what is your IQ. What is much more important is what is the environment that you are living in. And I will give you an example that I think most of you know. This child on the left is learning to walk, and his mother, or the woman on the right, is the learning environment. And she encouraged this student to walk. And the student can't walk today at this moment, but through the help of the woman on the right, he will. And when he will be able to gain another zone of proximal development, because, for example, he will be able to run or to do another things. And a good learning environment is an environment where the steps of learning are fast and quick. And it is also important to understand that unlike Pavlov, in this environment, the student may fail, and it is okay. It's not like in these exercises that you fill the right answers, and if you have one mistake, then you get a red mark and you are not good enough, and there are some that are better than you. Here, if you fall, then you just go up and continue from where you stopped. And Vygotsky said that what the child is able to do in collaboration today, he will be able to do independently tomorrow. And I think that this is what we want our students to do. We know that there are things that they can do, things that they cannot do, and we want to offer them an environment that will be able to expand the things that they can do all the time and in greater steps as possible. Education to think is achieved if we will summarize what Vygotsky has said by two things. First of all, we should give freedom and interaction, like the teacher and the student that learn how to walk, and we should provide non-judgmental feedback. Because if this child will fall down and we will treat him like in schools and we tell him, you can never walk, you are not good enough, then maybe he will never walk in his life. We don't want to do this to our students. And this leads us to the next stage. Now that we know how to teach, then the problem is, what should we do at schools? And we are focusing on what this webinar is about. So I will show you two methods that are used in schools to create learning environment that make the student think. First of all, we want an environment that will be related to the student world, what we call in education constructivism. We want it to be multidisciplinary because this is the real world. The real world is multidisciplinary. And we want the student to encounter ill-defined questions that don't have the right answer. Because ill-defined questions is questions like how things are working, what will be tomorrow, how is the best way to do this, and not questions like schools gives today. Schools with one right answer, and if you don't get the right answer, then you are not good enough. We want to foster teamwork. Schools don't foster teamwork because teamwork in Pavlov style is called copying. Because if I will do these exercises with my friend, then the teacher may be angry about me. We want to focus on the process and not the product. And the problem is how to evaluate this. And this is what this webinar is about, because we want this evaluation to be critical, which means non-judgmental. We should provide feedback, but this feedback should not be about good or bad. This feedback should be about these things that the student do, and maybe to give him an advice. The task of the feedback is to improve, not to judge. And the task of the feedback is to enable failure. Failure is very, very important phase. It's very important that we will know that failing is good, especially if you want to be creative. You have to know that maybe you will fail, but it is okay if you will learn from this failure. I want to give you an example for a learning environment that may encourage students to think. This is called STEM, and you see here an eraser. Every student knows what an eraser is, which means that if I will discuss an eraser, every student knows what it is. And STEM is basically about this method. First of all, for example, we say, what is the science here? We want to explain how it works. Well, for example, an eraser works with friction. This is a scientific thing, and if we understand the science behind the eraser, we can, for example, understand why it can erase pencil, but it cannot erase pen. We can deal with technology, how erasers are created, what are the methods, what are the ways. Of course, we can engineer the eraser. The eraser was invented by an engineer that, by mistake, before the erasers were invented, they used old bread to erase pencil from a paper, and he, by mistake, found out that a piece of rubber can do the same thing because it can create the same friction with the paper. Art, of course, there is a lot of ways to design an eraser that will fit different user and will give them different user experience. And of course, there is math. Math can answer all the questions that have quantitative answer, such as how much time this eraser will last, how much I can erase with it. But the problem is that, according to Vygotsky, this doesn't end here when we discuss about the STEM, because the question, the biggest question, is how to assess the process, not the output. Because if at the end I will ask my student how eraser is working, then I miss the whole point. The whole point is the process of finding how eraser is working, the process of asking the question, seeking for the information, thinking about the right questions, and not about the results. The essence of this project is to not, the eraser is not the subject of the lesson. The subject of the lesson is the student and the student thinking skills. And the eraser is just a tool, because I can do the same lesson with a pen or a pencil or a toaster. It doesn't really matter, because what I want that will happen to the student is that he will learn to ask questions and he will learn to see the world. Another problem is another situation or another learning environment that we can give to our student is robotics. We can give them challenges such as FLL or other challenges, and we know that they create a wonderful teamwork. It creates a wonderful interaction. The students just love it. They love to work together. They enjoy collaborating ideas. They love thinking together. They love reaching solutions together. It is a wonderful environment. It provides very, very good non-judgmental feedback, because the feedback is provided by the robot itself. If your assumptions were correct, then the robot will work according to your assumptions. If your assumptions were wrong, then it will not. And again, it is okay to fail. I mean, if I will, for example, compare the way students deal with failures in robotics, then if they fail like this in tests in schools, I think that they will not love this learning environment. But here, it is okay to fail, because every time they fail, it just gives them a new idea. And this is what the process is all about. But the focus should be on the process, not on the product. I mean, even if the robot is not working properly at the end, and the student did a very, very good design process, and they exercised all the 21st century skills, then it's very, very good, because failure is okay. The task of the learning is not the product, it is the process. And again, the question is how to evaluate. Should I evaluate the robot that they created, or should I evaluate them? And now we turn to evaluation and assessment in this learning environment, which is the focus. And I want to present here two tools that I use as a teacher. And the first one is, and I want to first of all emphasize that it is not a summative evaluation. It is not Pavlovian evaluation that should say the student you are good or you are bad, because it doesn't really matter what are the results. What is more important to me is the process that you got them, how you did it. And as formative assessment, what I'm going to focus in today is something like more Vygotsky, in which failure is success when we learn from it, as said by Malcolm Forbes. And failure is something that we pass through when we want to success. There is no way that we can succeed all the times on the first time. And it is okay to tell it to the students. It's okay. This is real life. This is the way we can prepare them for the real life. And I gave here two examples of how we can control the speed of our cars. We can control the speed of our cars either by looking at the speedometer and saying, I want to drive at the speed of 80 kilometers per hour, or I want to control the speed so that I will have a 3-second gap between me and the car in front of me. But I can never control those. Because if I will control the speed based on the speedometer, then I will not have a 3-second gap. And if I want to have a 3-second gap, then I have to leave the speedometer. And the same is for evaluation. We cannot teach both knowledge and thinking skills. We should decide what is important, and this is what should be this measurement should dictate what we do. Either we measure the speed or either we measure the distance, but we cannot control both. So the question between what we measure will define the way we will work means that if we will measure knowledge, if we will evaluate knowledge, if we will assess knowledge, then we will teach knowledge. And if we will assess 21st century skills, then this is what we will teach. This is what the student will want to do. Because in our system today, we are in a big problem. The government said, I want you to teach the 21st century skills from the one hand, but from the other hand, they give us standards. And standard is knowledge. And you can't do both. You have to decide whether you do skills or whether you do knowledge and standards. You cannot do both. So the assessment challenges is as follows. First of all, the resolution of the assessment should be very, very low, because it is very, very difficult to evaluate or to estimate the quality of what the student had done. And there is a famous in the Wall, in the movie Wall, where the student is coming to Pinky and he said that his song is complete rubbish. And the truth is, our students can do also something that looks rubbish to us, but maybe it will turn out to be something genius within 5 years. So we don't know how to evaluate, but we can use low resolution evaluation. We want the evaluation to show strengths, what is very good and should be improved, and what should be improved more, what is weak. But I don't want to use weak, the word weak, I want to use the word things to improve. And we want this feedback to be critical and not judgmental. And again, we want to show the student that it is okay to fail. Now, these are all things that do not live in the Pavlovian classical evaluation, because we want very high resolution. We want usually to show what the student didn't know. The evaluation is judgmental, and it's not okay to fail. Another problem is that when we evaluate works of the students, there is sometimes bias. And another thing is that we, as a teachers, don't get feedback on what we have done in the class. So all these problems, fear and appearance, self-evaluation, how do we create assessing tools that will change what we measure in order to change what we teach? Because again, it's like the car. If you measure the distance between you and the car in front of you, then the speed will be derived from this measurement. And if you will control the speed, then the distance between you and the car in front of you will be derived from this decision. So what should we measure in order to teach skills? And again, as I told you, I will present here two assessing tools. So this assessing tool is based on criteria. So we give a list of criteria, such as these criteria. Now note that this criteria does not evaluate the product that the students are creating. It is evaluating how the student performed, whether there was a good teamwork. Did they present three solutions? Did they present the problem clearly? Did they use the new knowledge? Did they explain their decisions? It doesn't matter to me if the decisions were right or wrong. It is important for me that they got a decision and they could explain. We decided to do it this way because we thought that ABC. It doesn't matter if they were wrong, if future will show that they were wrong or right. Then, for every criteria, we define a weight. And the weight is usually, I sum it to 120%, because I want also the students that did not have A's in everything will get a good mark. And I will show you how it works. Then we use low resolution grading. For example, in this case, we were asked whether to rank how this statement is correct in 1, 2, 3, 4 grading mark, which means that 2 is a little bit below the average, 1 is very bad, 3 is okay, and 4 is very good. And when we start to put inside the numbers, it is it's quite easy to see if something was okay or very good, or so the resolution is very low, only 4 possible answers. Then we average the grades and we calculate the final score based on the weight. And you see that at the end we get a mark which is at a very high resolution. The final score is with a high resolution. It is very fast. It shows pros and cons. And it is very easy to do it and build it. And also I can give students, for example, to assess themselves. I can do peer evaluation and just to average all the grades that were given by students, and to see, for example, in this case here, we see that one criteria, everybody thought it was very good. They thought that new knowledge was gained. So this is a strength. Probably this team do it very good. And we see that the decisions are not explained very well. But even though the decisions were not explained very well, still the grade of the students is quite high, and it is okay because it gives them a lot of room for improvement, but from a very good grade, not from a very low one. I want also to present to you something that we developed. It is called VIA. VIA is a personal learning assessment tool, and the task of VIA is to evaluate how, or to assess how students understood things. And now this is a tool that was invented, and we use it already in few places. And I want to show to you how it works. So the idea behind the VIA is to use statement-based learning. You see a robot on the right, and what the teacher do is this entire system is sitting on the web, so it can be accessed via any computer or smartphone. And what we do is we give the student a statement, and for each statement we ask the student to determine if the statement is true or false, and also to reason their decision. It is very, very important that they will reason their decisions, because reasoning is a very, very important thinking skill. It doesn't, it's not enough for me that you will say yes or no. You also have to explain to me why you think this is true or false. And this is high-order thinking. Now, for example, increasing the motor speed will increase the robot speed. This is a statement because it can be either true or false. And again, it's not enough that you will say whether it is true or false. You have to explain why. Well, and also note that this is very, very simple. I mean, increasing the motor speed will increase the robot speed, but it is not so clearly to say why. We can understand it inside, but how to say it in words? Now, the next statement will be, according to Vygotsky ZPD, it will be with a higher ZPD. Increasing traveling duration increases robot speed. Now, this statement, for example, is false. But why it is false? Increasing traveling duration increases robot travel. If we increase the duration of the traveling, will it increase the robot travel? Yes, but why? And increasing the wheel diameter will increase robot speed. Now you see that what is required to answer for each statement goes up as the numbers goes up, and this system is completely flexible because you can adjust the questions to the level of the student, and you can adjust the question to a different thinking skills. Because to answer each and every question like this, you need to use different thinking skills. Now, how the student answer for these questions? Well, he gets the first statement, increasing the motor power increases the robot speed. And when the student checks that this is true, a window is opened, and through this window he has to type in few words, maybe 3, 4, 5 words, why he or she thinks that increasing the motor power increases the speed. And I don't think it is very straightforward. I mean, it forces the student to think. Now, in this way, the student answers all the questions, and at the end, the teacher gets, in this system, also the student also gets a way to see how his answers are with the students, with the answers of other students, and what the teacher sees at the end is how all the students anonymously answered every statement. For example, here the statement is increasing the motor speed, the motor power increases robot speed. Well, for example, one student said that the motor turns faster and covers larger distance for a given time. Or the motor turns faster and covers something. The robot increasing the motor power improve robot performance. For example, this is quite weak reason. Or Another student is saying that increasing the motor power increases robot speed since the motor temperature will rise. Now, what is important for me as a student is to see how my student thinks. I don't know yet in this stage or in this phase which student gave me these answers, because first of all, I want a feedback for myself as a teacher to know if I was effective, if the student understood me. The assessment phase, in this case, is very, very fast because I can see all the answers for the students for this same statement. It is anonymous, and the teacher interacts with the students because I see how my student thinks. And it is very, very important for me as a teacher to know. I cannot know what my students are thinking because they are working. They are working with the robots, they are working in teams, they speak with themselves. I can't know what they think. And this tool enabled me to see how they think, how they express themselves, how they understand the system in general. Immediately after this, the teacher completes this evaluation phase, he gets a bar graph that shows what are the results of the student, how many students did select the right, decided whether it is true or false correctly, how did they explain their decisions, and we get this in 6 different levels because they can be either correct in the true or false, and they can be either have weak, very good, or partial explanation to their decision. But when you get all this information, you get a very, very good and high resolution image of the picture, image of the students, and you can see how the student understood and how the student answered for each one of the questions with a very, very high resolution image that show you, for example, that here in this exercise, probably there was a problem. Here in this exercise here, it was okay. And in another exercise here, there was probably a problem. And this gives me a hint, or it gives me also as a teacher a hint what to do in the next lesson, because I can see, for example, here that the student didn't really understood or didn't express themselves correctly, and I will address it in the next lesson. Another important tool is that I get also a student chart in which I get an average mark, and I see a lot of information that was gathered on the student during the answering phase. For example, how much time he spent or she spent on each answer, and compared to others. I mean, for example, if all the class knew how to answer this statement in 20 seconds, and another student it took him 50 seconds, it doesn't mean that this student is not okay. But it means that me as a student, as a teacher, sorry, I have to focus on this student and ask myself why it is so. Okay, so this tool, and the task of this tool is to gather information, a lot of information, and present it to me, and then use this information to be a better teacher and to help my students to be a better adults, to create a better society and just society. I want to thank you for listening to this webinar. It was a very, very nice experience to me, and I am now open to hear your opinions using the chat or any other tools that will be available.
Thank you so much, Oded. we have received a few questions. We have been running late, so I will pick a few of them. First of all, um, we really hope you all enjoyed the session with Oded. We will be sharing the recording of the webinar and the slides on our website on gocoderz.com, and you will all receive a link in a follow-up email to all participants in today's webinar with the slides and the recording. We'll take maybe 2 or 3 questions. And in addition, we invite you all to join our Facebook STEM group, where you can also communicate with Oded and ask additional questions. You can find it as presented on this slide, STEM for All, and join over 200 STEM professionals. A few questions, Oded, that came in. Again, unfortunately, we don't have time for all of them. What are your thoughts on democratic schools? Is it a good way to motivate kids and evaluate teachers?
I think I'm on the, okay. I think that democracy is a free environment in which people can talk, share ideas, and as such, it is a good environment. Usually when I'm asked this question, I give a very simple historic test, that experience that was done. After the Second World War, Germany was divided to 2. Some of the Germans lived in democracy, and some of the Germans lived in East German, that was a capitalist, communist dictatorship. We know that in most of the cases, people wanted to move from the East to the West. We know that in the West, the German engineers built Mercedes-Benz, they built BMW, they built Volkswagens, and in the East, they built this car that was called the Terrabent, that nobody wanted to ride, and you had to wait a year to get it, and it was polluting the air. And I think this is demonstrating very, very, very clearly what is the difference between democracy and tyranny. And unfortunately, most of the schools are not democratic. So I think that democracy in schools is very, very important if you want to encourage people to think.
Okay,
Waiting.
we have another question. What is the most ideal setup of a learning environment for best impact? And does it have to be linked to higher education learning?
What we can see, for example, even in the Israeli school system, is that the learning environment, for example, in the kindergarten, is very, very democratic, because the child can go to any toy he likes, he can play with the children he likes, he interacts with students. And as we grow up and we get to schools and we get to the matriculation exams, then this goes out. And we forget to give our students the learning environment that will teach them to think. For example, when a student is going to the matriculation exam, which is purely knowledge exam, then we sometimes as teachers tell him, don't think, just follow the steps and answer these questions. Learning environment is basically constructed from 3 elements, which are: what is the task of the student, what is the task of the teacher, and how evaluation is done. And if evaluation is done in a way that we evaluate knowledge, then it means that the student and the teacher will practice knowledge. I hope I answered the question, or not?
Excellent.
Okay.
So thank you everyone, and thank you so much, Oded, for today's webinar. Again, unfortunately, we were running slightly late, so we don't have time for all the questions, but we invite you to join the Facebook group and connect with other professionals and with Oded, and we will collect it on the group and provide it to Oded for answers. If you're
Every question
interested
will
in
be answered very with a large respect and love.
If you're interested in more information about the CoderZ and virtual robots, please do reach out to us through gocoderz.com. And thank you so much for joining us today, and we wish you all a great afternoon.
Thank you very much also, and thank you for joining this webinar, and hope to see you soon.